Hey, how's it going, guys? Daniel here, aka HashLips, and finally, we're at the stage where we need to set up our front-end environment to handle our application, our DApp, the smart contracts that we're going to be interacting with. What's great about this section of the series is that you can apply this setup to any other DApp that you create. You can use it to connect to any other contract that you create. So I'll sometimes refer to this video particularly to set your environment up. The environment we are going to be setting up in particularly is going to make use of Truffle, Ganache, and React.js. Now, it's important to understand that React.js is just a front-end framework to create front-end applications. Truffle and Ganache are the two tools that we're going to be using to, first of all, develop our smart contract locally, host the blockchain locally, and also migrate and deploy locally so we can test our application and the smart contract. We're also going to be making use of Metamask, a provider to connect to our blockchain and to connect to the actual smart contract and to interact with it. And this is going to give you great insight on how these two technologies work. Up until this point, we've been developing smart contracts in Remix, which is perfectly fine, but now we're going to move everything to the local machine, which you can do as well. If you want to follow along, you'll need the following tools, which is Node.js, Yarn, Truffle, and then Ganache CLI. So Node.js, Yarn is optional. You can use NPM. It's up to you. So I'm just putting the tools here for you to make use of. I'm going to use Yarn, but these are the tools that you can use. Secondly, Truffle. This one is actually the tool that will migrate our smart contracts, that will run our blockchains on Ganache CLI. Well, we'll run the blockchain on Ganache CLI and connect with it through Truffle, and Truffle will actually handle our contracts, deployments, and so on. So this will be all shown in this episode, so stick with me and let's get started. The first thing that we want to do is we want to run this command in the terminal, npx create react app, and then we want to give it a name. And the name we're going to give it is NFT game, just like so. Now what this will do is actually install the starter package for a React.js application very, very quickly, and we can then right off the bat start using it. We can also start up the application by running yarn start, which I'll just show in a second. And this is a convenient way just to show that we already have a running app. We already have a running front end. And I just want to make this perfectly clear so that people understand that we're not going to be merging these two things so tightly. It's really separate technologies that we're working with that we're going to integrate. So there we go. Our React app is set up, and you can see we can run yarn start. And once we do that, we will start up our development server, and it will spin up. And there we go. Now that we have the project started up, go and reopen that folder that was just created inside the IDE. This is just so that it's in the root folder of the Visual Studio or your IDE, or you can CD into it. I just like opening it up. Then I also moved my to-do text in here because next we are going to install a few dependencies that we need to have. And the dependencies we need to do and install yarn add Redux. I'm going to do them individually so you can see what we exactly need and talk a bit about it. So Redux is basically a state management system, and it also will need Redux. We might need Thunk, so install Thunk, Redux add, or you're going to say yarn add Thunk. Basically, Redux is a state management system. Like I said, it helps us to manage state a little bit better. Instead of using useState in our components, we're going to be depending on Redux. It's a better state management system to use, and also it's much better practice that I can show you in creating these dApps than just not using Redux, if I can put it like that. I'll go through that in a bit while we do this tutorial. Now, next we need to do yarn add React Redux. All right. And then we're going to add Web3 after this. So we're going to say yarn add Web3. So Web3 is kind of the web version 3, the webs that can actually connect to the blockchains and that has access to functions that is blockchain specific, that has utilities to it. It can do a lot of things, right? So that's why we need it, and we're going to utilize it, especially for when we get to using utilities and so on. We're also going to use it in combination with Metamask when we pick up our Ethereum in the browser, and I'll show you when we get to that part. So just install it for now. The next thing that we're going to install is styled components. And the reason why we need styled components is because it's a much easier way to actually incorporate CSS. Styled components is a way where you can write CSS, wrap it in a component, a HTML tag, so to say, and then have it be a smart component, a styled component. For instance, you can create a styled component of a div, and you can give it parameters and props, and it can work with that in the CSS, making it very easy to work with, and we'll get into that as well. Lastly, what you'll need is basically this. So we're going to need to say yarn add open Zeppelin contract. The reason why we want to add open Zeppelin contract is because remember when we referenced all the open Zeppelin contracts for our Solidity code? Yes, we're going to need it for that. And the reason is we've written our smart contract over here, which we're going to copy over in just a second. But we have these two lines that we are referencing in Github. But we don't want to do it in Github. We can copy and paste this exactly and it will work. It's just better practice to actually copy all the smart contracts into the project that we are working with. Okay, cool. So we are at the point where we have a basic React.js application, and there's nothing funny about this, guys. There's no blockchain things associated with this yet. Yes, we did install a few of the dependencies, but that's about it, right? And just make sure you have Truffle and Ganache CLI installed as well. I did not install it here in the video, but just make sure you have it installed and follow those tutorials. But basically what we want to just have a look at is just to see the folder structure over here. And the reason why this is important to just have a brief look at what files we have. You will unfortunately not have this to do files, so let me just remove it. This was just for the tutorial. But you'll have exactly this. Depending if you are using an NPM or yarn, you'll have a log file, a README file, a JSON file where all the dependencies are listed in, a git ignore file if you set up a git, and then also you'll have a source folder. A source folder is very important. This is where all the front end stuff runs in, like our components, our styles, and a bunch of JavaScript files. And then you have your public folder. This is the folder where you set everything up before you build it so that you know which files are static. And then also the node modules file folder. So what you'll also see in the node modules folder is the Open Zeppelin that we've installed. And if you traverse down here, you can go into the tokens and ERC 721. And these are the smart contracts that we'll be using. So just a fun fact about that you can actually see these things that we have installed. So next, the fact that we now know that this is just a normal front-end application and there's nothing funny about the blockchain about this yet. I just want you to have a clear understanding about this. So just again, we're going to now set up the part where we can start interacting with the blockchain, where we can deploy contracts and also set up our own local blockchain. Okay, so the next thing we want to do is actually run a local blockchain. Now, how do we do that? There are many ways of doing it. You can run the Ganache GUI and actually spin up a nice blockchain, have visual aspects to it and see it run. You can also just run Truffle develop, which is also something we're going to install, but we're not going to use that. I want to keep the blockchain in a separate terminal. So the thing that I'm going to opt for is Ganache CLI. So if you paste this command in your terminal, Ganache-CLI -d allow unlimited contract size. Now, the unlimited contract size part and the -d, you don't have to have that. You can just run Ganache CLI. But I'm adding this because sometimes Ganache has a limit that the block can handle when you deploy contracts, and it will tell you that the contract size is too big, but in actual fact it will still run on the block in the main blockchain. But I'm going to run this and you'll see what will be happening right now. And there we go. It ran the command and immediately you see a bunch of code. Okay. Now, a lot of people don't know what this is, and it looks quite challenging at first, but don't be scared at all. All this is Ganache spinning up a local blockchain for us, and it's nice enough to provide us accounts, Ether wallets, right? So there's wallet addresses with some Ethereum, some Ether in it, and then it also gives us the corresponding private keys. So this is the public key and that's the private key. You can't do anything with this information. This is a test blockchain, so usually you never share your private key of your address to anyone, but it's fine in this case because this is a test development network, right? Then the next thing that we get down here is just basically some stuff about the blockchain and what's happening and what gas prices and all these things. So you can see that the gas price is this, gas limit, and this is what I was talking about the other just now in the other comment where I said the unlimited block size or the unlimited contract size. This is just because of the gas limit. It can actually increase, so we shouldn't have any problems with that. Then we have this line over here where it says listening on port 8545. Now this is important. This is something that we'll refer back to just now. So I'm just going to keep this window over here. But in layman's terms, we just started up a blockchain, right? So you don't have to think about anything else apart from we have a blockchain running. It's running on this endpoint, right? At this URL, as you can put it, and that is the port, and then we are ready to start using it. All right, so this is the first step that you actually want to do. You don't have to do this first, but I mean, this is what we're going to be doing, is just starting up our blockchain. Next, what we actually want to do is connect to this blockchain. Now, how do we do that? The next thing that we can go and do is actually open the browser, and you need a browser with Metamask. Now, if we go into our Metamask and we open it right now, we can see that we are on the Matic network. We want to click there and go down to custom RPC. This is where you actually set up your custom RPCs to connect to different networks, and we need to do this as well to connect to our test network, right? So let's call this test, maybe test network for game. I don't know, we can give it a big name, but let's call it test network for game. And then our URL is basically going to be HTTP this whole thing, right? So HTTP 127.0.0.1 and then 8545. This is important because if you spin up the blockchain, if you spin this up using Truffle, it might give you a 745 or 9545 host, and what you actually need is this one, because that's the instance that we are running in the terminal right now, and it has to be running in order for you to connect to it. So if we look at the chain ID, you can actually click there and see what the chain ID is. The way I found out how it is by doing that and then trying to click save while it's in there, or put a wrong one in there, click save, and then it usually tells me that this is the chain ID. That's why I know to put 1337, okay? But in general terms, that is what the Ganache CLI chain ID is. And what are chain IDs? For instance, Ethereum, I think, is chain ID 1, if I'm not mistaken. But I know that the Matic network, the Polygon network, is chain ID 137. And then it so happens to be that the test network is 1337. So anyway, but you can save this. And now what you'll see is that we are connected to this blockchain, right? So we can go to the Ethereum blockchain or the switch to the Ethereum network, which is the main network, by the way, or we can go to the Matic network, or we can go to our test network for game, and that's what we want to do. All right, so there we go. We actually want to connect to a different address because we can't use any of these addresses. They don't have any ETH in them, and we need something to test with. So an easy way to do this is to open up our blockchain that we've started, the terminal, and actually go and import some of these accounts. Now, for our purposes of the game, we are actually going to import this account and this account. So we're going to import two accounts. To import an account, you'll need its public and private key, I believe. So let's see what we need. So let's go over there and click import. What we can do is paste the private key. So we only need a private key. So let's put the private key of that account in there, and then we'll do the same process by saying import account, and we'll select this one because we want these two accounts over there and over there to be imported. So we select the second one's private key, paste it and import it. And then you can see we've got 100 Ethereum in that one, and we got 100 Ethereum in count 10. So there we go. We've connected Metamask to our test network that we just started up by running Ganache CLI. So every network will work the same. You'll run a network, it will give you some endpoint to connect to, you'll connect to it, you'll give it the right chain ID, and it will connect to it. And whether you have accounts listed on there, usually when you do development, Ganache is nice enough to give us these accounts, to give us test Ethereum to test with. You'll see that this console has been logging out different things, and these are just events that happens on the blockchain. For instance, showing us the 100 Ethereum, Metamask is interacting with this blockchain at this stage, and that's how it's going to be telling us that there's some interaction. We'll also see this interaction once we actually deploy on our test network that we are running in here, what's happening. You cannot close this window and then deploy. If you close this window right now, what will happen is, or if you end the blockchain, what will happen is you won't be able to connect to it to your MetaMask anymore. So you'll have to spin it up again and then just connect to it. You don't have to set up the RPC again because it's already set up to point to that endpoint, but you'll just need to run it in a terminal for you to be able to access it. I hope that is very clear, because for the next part, we are now going to look at how we can install and use Truffle. So we have got our network running, our blockchain is running, everything is good. We've connected and added these accounts to MetaMask. You don't have to do that every time as long as you keep the blockchain running. But as soon as you close this, you'll need to reconnect the account. So just keep this open and running while you're doing development. But the next step that we need to do is finding a way how we can actually write our smart contract code in our dApp so that we use one project base and then also be able to migrate and upload it onto our blockchain. So previously Remix did that all for us. It kind of compiled and it uploaded it to a virtual blockchain in the browser. Now we need to do it on Visual Studio and get that smart contract to deploy on this blockchain. So how do we do that? So in your application, you need to use Truffle. Now, I assume that you've installed Truffle, and after installing Truffle, you're going to say Truffle init. And once you say Truffle init, what will happen is you can actually see it's already done, and here we go. So Truffle init adds a few files, and you can see they're listed in green over there. It adds contract, which basically has a starter migration contract in it. The migrations, and migrations we'll talk about just in a bit, but this is telling the Truffle framework which contracts to deploy. Then we get a test folder. In this test folder, basically you write your smart contract tests. Now, we're not going to be discussing tests in this tutorial, but it's very important to actually write these tests. We'll do that in another tutorial where we create NFTs on the blockchain and have people mint them just as NFTs. For this game, we're not going to do that because it will end up very long. But this is where the test would go. And then we have this Truffle config file. If we open the Truffle config file, you'll see that there's a lot of things that's commented out currently. We will uncomment certain things such as the Solidity compilers and so on just in a little bit and add a line of code so that we can make it more convenient for us to use. So how do we connect and how do we tell Truffle that we have a blockchain running on a separate terminal? It's simple. We need to reference our endpoint like we did in our RPC in our Truffle configuration file. So what we'll do is we'll select the Truffle configuration file and then scroll down to the point where you get networks. You'll see that there is a section that has been commented which you can uncomment. It's the development section. Now in here you can see that we are going to be connecting to this host, and if we go back to our blockchain we can see that it's the same host, and conveniently it's also using the same port 8545. And that's all you need to do for Truffle to know that we need to actually use this development blockchain instead of any other blockchain when we deploy. Next, what we can also do is go down to this compiler section and comment out almost everything. Well, uncomment everything. So what we need to do here is a few things. For development, you don't really need to specify this. So I'm going to take that out. Also Docker, I can take out. I'm going to leave everything as it is. For optimizer, I'm going to say this is true. And then for the version, remember we wrote our versions in 0.8.0. So I'm going to go ahead and do that. Once I save this, there's one change that I need to do before we test launching on this blockchain. You'll see that here in the contracts folder, we have a migrations.sol. Now the reason why this won't deploy, and I'm just quickly going to show you how to deploy it. What you can do in the terminal is say Truffle migrate, and then I always add migrate. I always add -- reset. Okay, so the reason why I do that is because it resets anything that has been deployed that looks similar, just to make sure it's up to date, and replaces it. So I'm going to hit migrate and see what happens. Hopefully we've set up everything correctly and it would start to deploy on this blockchain. You can see and you can notice that something actually happened over here. So what basically happened is it deployed, it ran, and everything looks successful. Okay, so you can see that there was a transaction that took place on our terminal. This is now a blockchain running, remember. And also in this terminal over here where we ran the command, you can see that it went successful. It cost us this 20 wave for the transaction, and well, this is the gas, that was the gas price, and this is the gas used, so I guess that plus that's the transaction cost, but there it is, the total cost. But needless to say, this actually worked, and I thought it's going to fail because usually these contracts have a Solidity compiler version that is lower than the 0.8 that we are using, and that's why I thought it was going to fail. But yes, this basically says that anything from 0.4 to 0.9 is fine to use, which is fine. Okay, remember in our contract we use 0.8 explicitly, so that's why we're using that compiler version. So everything is set up ready for us to go and rock, right? So one last thing that we need to do is actually just add a line in here, which is this. And on line 83, I just added this line. What does this actually tell us, and what is happening behind the scenes? So this is the contracts build directory. Now, the reason why I have to add this line, if you look above the contracts folder, there's a new folder called builds. Now, the builds folder contains contracts and migrations.json currently. And the reason why it says migrations.json is because we had migrations.sol, and it's in our migrations folder. We said this needs to go into the blockchain, and the blockchain has a way of printing out how it perceives this whole smart contract. Okay, it alongside with some bytecode, it prints out this ABI JSON. And what is the ABI? In layman's terms, it's just directions and instructions for a program to read a smart contract and see off the bat what inputs, what functions, variables, and everything it has, so that it can interact with it and on a much nicer way. Okay, a side note, when you actually connect to any smart contract, you'll need the ABI and the smart contract address, just on a side note, which I'll show you in a bit. But basically, the reason why we added this line just now, before I'm going to redeploy it, is because you notice that it's sitting outside of our source file. Now, React has problems to reference any kind of source files outside of this directory, and we actually need the contracts to be deployed, or at least the ABIs of it, to be deployed inside here, so we can have a nice and easy access to these contracts that we deploy. And these are not the actual contracts, these are just references to it. So what I'll do is I'll go up there and actually remove the whole build folder over there, and we've added this line on line 83. I'm going to rerun the command I just did, truffle migrate and reset. Hopefully what will happen now is everything will also be successfully deployed, and we can see it was. Again, we can reference our terminal, and we can see that there was another transaction on block 3 that was created. And there you can see as well that it went through successfully. And we notice that that builds folder is not here anymore. But if we open the SRC folder, the source folder, we can see there indeed is our contract. And we only have migrations.json. The next thing that we want to do is actually bring over the smart contract that we have built on Remix. So we can go over to Remix and we can copy this whole smart contract that we have there. We can copy this, go back to our IDE, and inside contracts over there, we can create a new file, and we can call this lipstoken.sol. Okay, or maybe we can call it liptoken.sol. And then we can paste everything in here. So everything should be fine, but the only problem here is that we need to kind of import this GitHub files from our node modules. So that's what we're going to do now. So how do we do that? We need to open our node modules and see where it's located. So we can see that there's at Open Zeppelin. Okay, so I'm just going to copy that. But let's open Zeppelin. And we can see right under Open Zeppelin, there's a contract folder as well. So we're gonna replace that up until the contracts file. Okay, so let's find where that is. So over there, and we're gonna replace that there. Gonna do the same for that one. So now we are making reference to the Open Zeppelin contracts directly in our local application, because these contracts already exist there. And we know that this works because if we hold down Command and click on this file, it actually takes us to the smart contract and the reference to it. But now that we have this happening and working, the next thing that we can do is set up a migration file for it. So you can open the migrations folder. You can right click in there and say new file. And then what we can do is call it to underscore, let's call it lip token, and let's keep to their convention, lip token migration, like that. And I have no idea what file extension this is. This is a JavaScript file extension, so JS. Okay. So we're just going to call it lip token migration. And if we look at what's happening in this migrations file, we can just duplicate and paste it in our newly created file. The next thing that we need to do is we need to actually reference the artifact that we are going to create. Now the artifact name you'll get here, so we can copy and paste the lip token, and we can paste it where it requires this artifact. And we're just going to call the constant the same, and as well then basically in this deployer function we needed to deploy this. Okay, now you can do a lot of concatenated deployments of smart contracts. Okay, we did not need to create a whole new extra file for this. We could have basically just imported another thing and then deployed another smart contract there. There's a lot of ways of doing this, and also these deployment functions, they are asynchronous, and once it's deployed it actually returns you the contract address, so you can go .then and then use the address as you can use the address for something. Okay, but for our purposes we're going to keep it simple like that, and that's all you need to kind of import our token contract. Is create a contract over there and add it to the migration. It's very important that you use the underscore, 2 underscore, and 3 underscore, the more contracts you have if you want to deploy them separately. And then once we have that going, we can see how we can deploy this. So all you need to do now is run truffle migrate reset again. We can open up the blockchain to see it running, and there it will start kicking off functions, and we can have a look at what happened just now. All right, so let's check it out. The first migration went perfectly fine. Okay, this migration replacing migrations worked fine. Then lip token didn't work. And why didn't it work? So it says lip token invalid number for a parameter identified. Got 0, expected 2. Okay, this is perfect for this use case, because sometimes you run into these problems. And this is not a problem, this is just our stupid mistake. But what basically happened is, let's have a look at what we are doing here. So what we are doing is, we are actually deploying the contract lip token. But lip token has a constructor, and a constructor that takes in a name and a symbol. And it needs those two constructor parameters in order for it to deploy. And how do we add parameters? What you can do is right after your contract definition, you can put a comma, and then this is where you actually put the parameters in there. So what we want to do is the first parameter should be the actual name. So let's call it lip tokens, and then we can put another comma, and this time we're just going to call it lips, right? Lip tokens, and then lips. And once we save this and save this migration file, when we rerun it down here saying truffle migrate reset, hopefully now everything will be successful. So let's open up our blockchain again and check it out, and boom, there it goes. It's successful, everyone is happy, and we can see that lip token did indeed deploy. Perfect. I'm very happy so far of our setup. The next thing that we actually need to do is we need to kind of set up a way of how to connect to our smart contract now as soon as our application launches. But before we do that, I would like to add to a concept, which is our styled components, just so that we can have a little bit of a UI that we can write. I also would like to add Redux, which is a state management system, like I also explained to you earlier. These two kind of frameworks or ideas, I call them ideas, but these two functions and these things that we're going to implement now will greatly help us to improve our DApp and how to enter the DApp. For instance, to check how are we going to be connected to Metamask? Are we going to be connected to Metamask? Are we on the right network? And so forth. So that's what I'm going to explain in the next part of this video. So up until now, you guys have learned an important bunch of concepts, and I know I've been blabbering about and teaching so many things at once. So I want to move a bit in a different direction where I actually place some code inside of these folders. I'm not going to code and type every line of code out by hand. This will take a long time, but I'm going to explain every line of code so you guys know exactly what's happening so you can follow along. You can also get the code repository from the GitHub repository that I'm going to link in this video. But apart from that, let's get started. Let's look at what state management system we're going to be using. Again, you can do whatever you like to. If you know React, you can use state, you can use class-based components, whatever you want to use. We are going to be using Redux. I find it's much easier to work with in the global space. So let's get started. In the source file over here, what we're going to do, I'm going to paste a folder in here called Redux. Now, inside the Redux folder, what we'll have is a store.js, which we'll get into now, and a blockchain folder. For each piece of state in Redux, we will have a folder like this. We might also have a data folder in here at some stage where we're going to fetch the data from the contract. For now, the blockchain folder, what it holds are two files, and each blockchain or each state in Redux will have two files exactly the same. So I'll get to that in just a bit. But let's close this folder and look at the store. What the store basically does is we import everything we need from Redux. We also import Thunk, and we import the blockchain reducer. The blockchain reducer comes from the blockchain folder and inside the blockchain reducer. Then what we do is we concatenate everything in here with the combined reducer function, and then we add middleware, which is Thunk. We compose everything, and then in the store what we do is we give it our root reducer, which has now all the little bits and pieces. So there you can see we have our first bit of state called blockchain. And then we configure the store and export it. Perfect. The next bit that we have to look at is the blockchain folder over there. The first thing that we can have a look at is the reducer itself, the one we just imported. What is a reducer? So how Redux works is it basically works with an action and reducer kind of model where you kick off an action, and an action might be anything that you want to change the state in some kind of way, right? So you basically kick off an action. It can have a bunch of logic, and it comes into the reducer, and depending on which action you kick off, it's going to do different things, right? It's going to change the state in a different way. So for instance here, we start off with the initial state. Our initial state of the blockchain, right, what we called it now, it's not the actual blockchain, but we could call it anything we want to, has a loading, an account, a lib token, a Web3, and an error message. So once we try and connect to the blockchain, which I'll show you in this video, we're going to kick off this connection request. This in turn is going to set everything to the initial state as it was before and set loading to true. This happens because we want to clear out the state and the old things in it and make sure we have a clean slate, and then set loading, because we're going to load a bunch of stuff and we might want to display things in the client to the user that something is loading. Upon success, we're actually going to kick off the success action, right? And then what it does is it says, well, return the state to us as it is. Don't do it the initial state, just the normal state. But then turn loading to false and fill in these values that we have up here in our state, which is initially set to null, and an empty string. And lastly, if it fails, set everything to initial state, set the loading to false, and set the error message to whatever we set it in the action. Okay, and then basically we have an update account, which is an extra state change where we just update the account. This we're going to mainly use when a user switches accounts in Metamask. Let's look at the actions. So if we look at the actions, we basically import these two things, and the reason why we import them is actually to make use of it and connect to the blockchain, but also connect to the smart contract that we've created. So what we have here is little actions. So we have a connect request, we have a connect success, a connect failed, and an update account. You can see that for the success and for the failed, it takes a payload. Payloads that we use in the reducer. So let's look at this. We remember that the connect request has a type of connection request. If we look at the reducer again, we see that this is the very first one we had a look at, and it does this. If we look at what happens when the connect success kicks off, we pass it a payload, and if we look in the reducer, you can see success is kicked off, and it does all this to the state, plus it uses the action payload that we sent through. Again, the same happens for failed and also update request. We then create a function called connect. Now this is probably the most important function in your dApp because this is the entry point to the application. And let's quickly go through it and discuss it. So what happens here is we have a connection function where we say connect, and we have an arrow function. We then asynchronously return and we pass in dispatch. We have to dispatch actions, and the actions that we want to dispatch all sit right above this function. The connect, connect success, connect failed, and so on. So basically here on line 36, we dispatch our first action, which is the connect request. Like we said, connect request will kick off a subsequent call and then go and change the state, not into that one, but into this one, where we set it to loading. And this is a pattern that I've always followed in my code, where I do a loading, a success, or failed, because that communicates well to the front and we can do interesting stuff with it. Next, on line 37, we have window.ethereum, and to check if the window has a Ethereum capabilities, right? What does this line actually do? Well, if you have Metamask installed, it means that Metamask, the extension, actually turns your browser into a blockchain compatible browser. So thus, this Ethereum object will be attached to the window. If you see on this if condition, if we go to the bottom, you can see on the else statement of this conditional, we say this failed, and we kick off, we dispatch another connection failed, well, connect failed action, which we pass in a payload. The payload that we pass in will then in turn in the reducer file, if we look at that, will go and update the error message to the payload that we've sent through. This payload in this case will say install Metamask because it failed on the first if conditional if the window actually has the Ethereum object in it. Next, what we want to do is we want to actually initialize a new object and call it web3. We have to import web3 that we've installed as a dependency before in the beginning of the video. After we initialize web3, we set it to a new web3 instance and we pass it a provider. The provider that we are passing is actually the Metamask provider that it picked up. After that, we do a try and catch block, and in this try and catch block you'll see that we do a bunch of things where we try and get the user's account and we get the network ID. I'll explain these in just a bit, but let's go and check what happens if this try catch block fails. So if we go down, the first one, remember, was we did not pick up Metamask. The second one, we simply dispatched that something went wrong. The case where this will kick off is very slim, because once you have Metamask, something that can go wrong in connecting to the Web3 is very slim, but it can happen, and that's why we have this catch over there. After we have passed the try catch block, we go and we do a few things. So what we do is we actually have a way of getting the account that's sitting in Metamask. And how do we do that? So we know that we have this winner.ethereum object, and we can call this as an asynchronous function and await for it to say, well, request, and the method is ETH accounts. This will return to us an array of accounts. And the array of accounts that it will return to us is actually all the accounts that you have connected to this app. Okay? So currently it should have this one plus the other ones that's also connected. And that's how we get access to those accounts. So once this has awaited for this object to resolved, then we actually will get an array in the accounts. That's why this is referenced as accounts and not account. So if you want to get the first account, what you can do is say accounts 0, and that will be the current connected account. Next, what we have is network ID. So if you want to get the network ID, remember when we actually added the RPC, we had to give it a network ID of 1337. This will actually pick up the actual network ID that we are running. So this should technically be 1337. And how we get it is actually we await for the net version. And this is the way you do these requests. And this will actually spit to us out 1337, I believe. And then the next line, what we do is, this is for local development, but we add this. When we do a live deployment, I'm going to change these two lines, and you'll see how we'll do that. But for now, we get the lib token network data. Now, how do we do that? We actually go and look inside the libtoken.networks. So the lib token is actually we actually get that from the libtoken.json, the actual JSON metadata that we've built. So if we go down inside our source file and we go into the contracts that was built and we go into libtoken, if we just do a simple search for networks and we go down to networks, network, we can see that there's a network, there's also a network. Let's just go and see exactly what we are referencing. Libtoken networks. Okay, so there we go. We have networks, but it's somewhere down here. Let me just see. Solidity. There's an ID. I'm trying to find this for you guys, just to show you how it works. Okay, but basically it finds it in here. We'll have to do a console.log at that stage just now, and then I can show you guys that. So then after it found the network ID, I just call it network data. And then we actually get the network. We actually get the opportunity to go forward. If this conditional does fail, it means that we can't pick up the contract on our network. And if it fails, it means that we are not on the correct network. And that's why this else statement is here. It actually says to us, change network to Polygon, because we know eventually we are going to deploy on the Polygon network, and that's where our contract will live. But once this if statement is fine, we are going to create a lib token, and this time we are going to create an instance of our smart contract. And how do we do that? We actually call the web3.eth, and we say contract, and we pass it in two parameters. We pass it in the lib token ABI. So what this is, if we look back in our contracts, if we go right to the top, we can actually see that the ABI is right over there. So we can just go libtoken.abi, and that's exactly what we do here. We sent the whole ABI, the structure of the smart contract. Next, we actually want the address, and the address to this smart contract is actually this contract over there. So if you look in your terminal, you can see that once we've deployed the smart contract, we actually do have the contract address. But this is also saved in the JSON data when we migrate, and that's why we have the conveniency of using it like this. Okay, so after that, we do dispatch our success, and I guess it again, there it is, and this is using the Redux. We send it in payload, and the payload that we send to the success function is we send an account object, which then refers to the first instance or the first object in the array. Then we send the lib token, which is actually the contract that we've created right over there. And lastly, we send an instance of the Web3 that we've initialized right at the top. And this is for if we want to make use of it throughout the application. Next, two things that we add are two listeners. We have a listener for when accounts change and also when the chain changes. The accounts change is when you switch accounts in Metamask and you switch to a different address, and the chain is if you switch to a different network altogether. This will kick off a window reload, and then in this one we'll just dispatch the update account Redux function, pass it in the new account, and it will update. So it will call this action, it will go to the reducer, it will update our state over there, and it will just assign the new account. This is important because users will do that, and then we need to have the new account ready. And this is the whole explanation of how to get this done. Basically, we dispatch this one, and this dispatches the request. So we can probably just call this, but this is the last function that happens there. There are some commented out code in this file for now. I am going to hook this up and then show you when we add our second layer of state, and then we'll be able to load data. But before we do that, I actually just want to show you how to do the rest of the Redux binding so that you can actually start using Redux. Okay, so the last thing that you want to do to make Redux work is we can go ahead, and I think just want to make sure that we haven't changed anything in this file. I'm going to save that. And then we're going to the index.js, and we're going to import two things. The two things that we're going to be importing is the store from our Redux folder that we have there, this store, and we also want to import a component provider from the React Redux. We can get rid of this for now and just put it in its place provider, and also end the component here with provider. Next, what we want to do is just provide a store, which is going to be the store to the provider. This means that our whole app from the root file will have access to all the Redux state. The good thing for us to do now is actually go and log this out. So stick with me, and I'm going to show you just briefly how we're going to log this out, how this is going to work, and how we can test if we can actually connect to the blockchain. So firstly, what I want to do is just like I mentioned before, I want you to see the contacts, how it prints out. So what we're going to do is we're going to say console.log, and here what we're going to do is say, no, this is not the contracts, but this is the account. And then for the account, I actually want to only choose the account, but index 0. And that means we'll get the first account. The next thing I want to log out, which we were not sure about, which I probably should have been, but is the network ID, because I really want to see what it is. I think it is 1337 if we are connected to this network, but we'll log these two things out just as tests. Perfect. The next thing that we actually want to do is we want to go down and have a look when we go to our app.js. In our app.js, this is just the base file and structure of our application. If we open the React app, we can see that there's this little text file, learn more, and an image that's spinning. Now, this is exactly what this is. There's the image, there's our text, and there's also the learn more tag that we can go for. What we can do is we can actually say we want to import something, and we want to import use this patch from React Redux. So we want to import dispatch from Redux, and we also want to import use selector from Redux. And basically in here, what we're going to do is we're going to say, well, const dispatch is equal to use dispatch. And we're also going to say that we want to grab the state. So let's grab that state. We need to grab the blockchain. So what I'm doing is I'm grabbing the blockchain state that we have defined over there, right? And in our reducer, if you remember in our store, we said that our reducer will have a blockchain state. And I think how we get to it is we say that there's going to be some kind of state, and we have to say this will be state dot blockchain. And this is how we actually grab the state from our current instance of Redux, put it inside this variable. To make sure this works, we can actually render it, right? So let's go and actually console log it to the browser. So what we can do is I can actually in here say that we want to console.table. Table is just a nicer way of logging on the browser. So when we run this application, and we can just for a brief moment make sure that this is running. We are running this, right? If we're not, let's just say yarn start at the bottom, just to make sure that this is running, so we can see this logging out. The use dispatch that I've added in here, we're not going to use yet, but I just wanted to add it here so that we can use it immediately after this example. Okay, so we have obviously messed what up? Dispatch. Great. It will help if we spell these correctly. All right, so let's go. Let's inspect what's happening in here. Let's go to the console. Let's open it up and let's see. Cool. So console was cleared, and there we go. There's our object, and we can see that we have got accounts null, error message is null, lib token is null, and false. Okay, so it's false because that's how we kicked off the application. It gives us the initial state. We don't see our logs of the account and also the ID because we haven't actually called connect from our Redux actions. So what do we need to do? We need to import the connect function inside our app.js. And how do we do that? So we say import, and we want to say we want to have the connect function, and where are we going to import this from? So this will be imported from Redux. We now just need to see where does it lie. So we're going to import it from Redux, from the blockchain, and from the blockchain actions we want to use the connect. Now this is why we actually imported dispatch, because we need to be able to use dispatch. Now we can't just call this function off the bat. When you're working with functional components, you'll need to import, let's just import React, and also let's import use effect from React. Okay, we need to actually create a use effect down here. The reason is because otherwise we're going to have too many re-renders in our Redux. So what we can do is, if we want to use dispatch, just put it as a dependency as well in there. And we're going to dispatch the actual connect function that we've created. So now what we'll see is a bunch of renders of the block. And that's just because we haven't placed the console.table inside the use effect, but the other one is. So when we refresh this or reload this, let's just see what happens. And there we go. We actually have a bunch of stuff happening now. So, okay, that makes a lot of sense. So our network ID was not 1337 at all. So actually we can copy this network ID just in a second and check out what it is. I just want to change this block thing, but for now we can actually check what it did. Okay. So remember what I said, we are going to get the account, which is this account. And if we verify this, we can go up to Metamask and check that our account also starts with X0x90F. And there it is, 0x90F. And then the network ID, which I was sure of was 1337, is actually this big number. The next thing that we can have a look at is previously our table showed this, where it was a bunch of null values and loading was true. But now we have all these objects filled in here and it's too difficult to read, so I actually expanded the object below here so we can see. We can see that our object now returns indeed an account that was added there. And we also have our lib token, which is the actual contract that we have created on Remix, that we've deployed, and we have an instance of it inside our application. And then loading is false again, and we have also another instance of Web3 where we have utilities, like I also explained. But what does this mean? It means that we are ready to use the application. Remember that in our code, we also had in the actions, we also had these two listeners. Now these already are working. So if we change the accounts, then we should see an update in the account. So let's go ahead and quickly do that and see that our account changes. In Metamask, let's select Metamask and let's select a different account. I'm going to say connect. And again, there we go. We can see that now we connected to a different account and that works perfectly fine. We can switch to the other account again and we can see that Metamask will kick off again and turn it to the other account. So there you have it. There we already have things working, connecting to the blockchain, and we can now start printing them out. So for the last section of this video, because it's very long, I'm just going to end by having a look at that ID that we thought was 1337, just so that I don't go mad, because I really want to know what it is. So we can go to the lib token and we can search for that. And indeed, there we get this network. All right. And remember, so if we can get this network, which is just the test network now, we can actually have access to the address of the smart contract. And that's how we get to that when we reference this lib token network data dot address. And that's how we get the address. So that's basically just how I set up my smart contracts. The last, the connection of the smart contracts. The last thing that we can do now is, because we have the blockchain object, we can actually do something interesting. So we can actually change the code or the text that's in here and say, well, please look at the account, and we can open our braces and say, we want you to reference the account. So what will happen is there we can see that the account's printed out. Okay, so it's a bit small at the moment because it's on a mobile device, so maybe we can just do it responsively. And there you go, there's the account. So because all of that logic is now set up in place, we can switch accounts and you can see it switch. And we can switch it again and it switches back. Remember, we also have a listener if we change network. So if we go to the Ethereum network, what happens? There is no account. We do not have a actual contract on this on this chain. So because we didn't deploy it on the Ethereum network, and it will tell us here in the error message, change to Polygon network. and that's what we should do. So not the actual Polygon network, we need to go to our test network for game, because that's what we set up. But once we do that, it should update, and then when we refresh, it should give us back our address. So we have all the tools ready right here to now start pulling in a little bit of styling and actually pulling in the data from our smart contract. That I'll do in the video after this one. I feel like this was a long video, but if you've stuck with me through this, it means that you're really keen on seeing the rest. So thank you so much for that. Remember to share this with your friends and like, subscribe, and put on that bell icon, because that helps me out very much. Thank you guys, and see you in the next video.